Let's take a look at some applications of our inverse functions. So this first one, we have a position function. And for that position function, we have inverse tangent of 1 over t. Or t to the negative 1, however you want to write it there, for t is more than or equal to 1/2. So we want to find the velocity at t equals 1. So we want the velocity function, which is going to come from our derivative function. So we have chain rule here because we have an outside function of inverse tangent, inside function of 1 over t. And actually, I am going to rewrite that as t to the negative 1. I don't particularly like having all these negative 1s hanging out because, as a good refresher here, this negative 1 right here is on a function, and that means it's an inverse. So it's just telling us an operation. This negative 1 on a variable is an exponent, so we're raising it to the negative 1 power. So even though they look the same, they're doing different things. You just want to be very careful of that. Okay, my inverse speech is over. Let's take the derivative. So taking the derivative of inverse tangent gives us 1 over 1 plus x squared, but instead of x being squared, we're going to have t to the negative 1 being squared. And then we're going to multiply that by the derivative of t to the negative 1, which will be negative t to the negative 2. And then we'll go ahead and simplify. So this will be negative, let's do a few steps here. Negative t to the negative 2 over 1 plus t to the negative 2, which will be a negative 1 over t squared is going to move down here and multiply with a 1 plus t to the negative 2. And that's going to give us negative 1 over t squared plus t to the 0, which is just 1. Okay, so there's our velocity function, and we want to evaluate at t equals 1. So we're going negative 1 over 1 squared plus 1, which is going to be a negative 1/2. And they don't give us any units, so it could be feet per second, meters per minute. Don't know, but that's our velocity. It's negative 1/2. Okay, say we want to find the equation of the tangent line to inverse sine of x at x equals 0. So our inverse function, our derivative, I might be switching those words up too much. The derivative of inverse sine of x is 1 over root 1 minus x squared. Okay, and again with the equation of the tangent line, we're looking to fit y equals mx plus b. And we need to evaluate the derivative at 0 so that we can get the slope out. So this is giving us our slope, 1 over root 1 minus 0 squared. So we're going to have a slope of 1. Then from there we need to plug a coordinate in. So our function is inverse sine of x, and we're plugging in x equals 0, which means our y coordinate is inverse sine of 0. And let's take that to the unit circle to see what's going on. So again, what's being input into inverse sine, that's a y coordinate on our unit circle. So what we want to do is look for where on the unit circle do we have y coordinates of 0. Well, that'll be happening here at 1, 0. It'll also be happening out here at negative 1, 0. So again, it's not an angle measurement in there, it's the y coordinate because it's reversing how we work with sine functions. Now, with our inverse functions, and there's a review if you need it, of these inverse trig functions where we look at them over certain intervals so that it remains a function. And for inverse sine, we look from negative pi over 2 to positive pi over 2. So with that, our one and only solution is going to be coming from this coordinate 1, 0. And what we're interested in for the output, so as we're evaluating this inverse sine of 0, we want to know what the angle measurement is. It's the angle that's the output. So here we have an angle measurement of 0 degrees, 0 radians. So our coordinate is just 0, 0. So plugging in 0, 0, that's going to give us a b equals 0. So our equation of the line is just y equals x. And we could confirm this with Desmos. Let's in fact do that just real quick. If we want to, we could graph our inverse sine function. So sine with a -1 of x. And we just found the equation of the tangent line of y equals x. And if we zoom in, we can see those line up nicely together. So that red line is our inverse sine of x. So that's where it's going from negative pi over 2 to positive pi over 2. As far as our output, the other direction along the y-axis. And then we're seeing from -1 to +1. But then at x equals 0, that line y equals x, where we have a slope of 1, is making a nice tangent line right up to our graph.